This video is based on meta-heuristic optimization in software testing. In this video, we will try to understand how we can solve software testing problems using meta-heuristic optimization algorithms. For example, in this video, we will try to understand how we can apply GWO optimization algorithm to solve test case prioritization problem in software testing. Certain topics are covered in this video. First, we will start with introduction to the software engineering. What is software testing and its objective? What are the test cases and how we can design test cases? That we will understand with an example. Then we have certain testing levels and tools. And after that, we have what is search-based software testing. And then we have different design strategies for software testing. What is the role of meta-heuristic optimization in software testing? Certain challenges. And in the end, we will try to solve test suite prioritization problems using GWO optimization algorithm. In this video, first we will try to understand the software testing basic fundamentals so that we can easily understand how we can apply a meta-heuristic to solve software testing problems. As you can see here, this is the software development life cycle. It is the pictorial representation for any software development. So it is the time period when any software is created and ends. First, we have the requirement phase. Requirement phase is also known as the requirement analysis, or you can say the specification phase. In this phase, our aim is to understand the customer requirements. After that, in the design phase, we will transform the customer requirements into a structure. So in this phase, work is documented as per customer requirements. After this, we have the implementation phase. This is also known as the coding phase. In this phase, we will implement or code the design. After implementation, we have the test phase, that is the testing phase. In this phase, we will check the quality of the developed software product. So we will execute the program to find faults. And here, testing is done for both valid input and invalid input. Why? Because we want to resolve as many faults as possible. After testing phase, we have installation and checkout phase, and after installation, we have the maintenance phase. In the maintenance phase, error correction is done, and then we have some time software retirement phase. So this is just the total time period when any software is created and ends. As you can see, for any software we have different phases. So among all, we will focus on the test phase. So we will focus on software testing, because in this video we will try to understand how we can solve the test suite prioritization problem using GWO optimization algorithm. So now we will discuss about software testing. As we know, software testing is very time consuming, costly. Our aim in software testing is to identify all the faults exist in the software product. Why? For the better quality software that is as per customer requirement and without any fault. Suppose we are testing a program, and for testing you can see we have input in the form of test cases. In software testing, our goal is to design sets that contain minimal test cases, or we can say design test suite that contain minimal test cases. You'll notice that here we introduce new terms such as test cases, test suite. In upcoming slides, we will cover what is test case, test suite, fault, failure, all in detail. Now you can see here we provided the input in the form of test cases to this program. Now we will observe the program output. If program output is matched with the expected output, then this program is considered pass. If the program output is not matched with the expected output, then program fails. So suppose program provide unexpected output that is not matched with the expected output, then we will consider this program fails. In case when output is not matched, we will note the condition under which the failure occur so that we can correct that later. Now we have different software testing objectives. For example, find error, find faults, and discover the undiscovered errors. Discover the undiscovered error means there exists some error that are not discovered yet. They are unknown error and we are not aware of such errors. So here, to solve such problem, we can design good test cases. And then you can see here, we have to uncover the different classes of the error and then reduce the software failure risk, reduce the software testing cost, and you can see different types of costing: design cost, maintenance cost, system cost, documentation cost, test case execution cost, and all. Now we will try to understand what is error, fault, failure, bugs, test cases, and entire process. So first we have error. As we know, error is human and probability of human error is higher than the machine error. So here, error is any mistake that is done by us, and error will occur in the form of syntax error, and or error can be in the specification misunderstanding. After that we have fault. Fault is the representation of error. Faults are the incorrect steps in the data flow diagram, ER diagram, or in the source code. Now we have failure. Failure, this is the representation of any error. And failure occur due to faults. And the faults are the incorrect steps. Done? So here, failure occur due to faults. When any faults execute, it results software failure. And failure is dynamic. It is not static because we have some undiscovered faults or error. They are not discovered yet. Then we have bugs. Bugs are also known as mistake bugs, and bugs occur due to the developer mistakes in the code. After that, you can see we have test cases. We use test cases for the testing purpose, and test cases are designed to find faults in the software. That's why in this program we provided the input as test cases, because test cases are used to find faults in the software, and we are doing here software testing. Now, test cases are developed, reviewed, used, managed, and saved. Test cases describe input statements and expected output statements. Input statements are in the form of preconditions, actual input, and output is expected output, that is the actual output, and post conditions. And we will consider the test case successful if it succeeds to uncover the unknown errors that are not yet discovered. After that, you can see this is the testing process. So first we will design the test cases, and when test cases are designed, we will prepare the data set for execution. Then we will execute the test data set, and then we will obtain the results, and then we will compare the results whether we obtain the expected output or not, and then we will generate the test report. Here you can see we have certain parameters for the test cases. For example, test data, test case ID, steps, expected output, actual output, and other. Now you can see here we have test report. Test report means the test completion matrix. This matrix contains the details about number of tests executed, number of tests passed, number of tests failed, number of tests rejected, and number of tests accepted. Now we have test suite. So when the test cases are combined together, they generate the test suite. States for the test suite: active state, complete state, and in progress. Now we will try to understand that how we can design the test case. Done? As time and again I'm saying that we will compare the program output with the expected output, then we will consider that this program is passed or failed. Now we will try to understand that what is the expected output and what is the input and what are the test cases and how we can design. So for example, here we have a program. In this program, we will determine the previous dates. and when I'm saying this word dates, then in your mind month, week, days, year will pop. So they are the input. So here for this program we have input as day, month, year, and output, this is the expected output that we expect from this program. So expected output is in the form of previous date, that is our main goal, and invalid input date. Now suppose today is 18 February 2022. So according to this program, then I will give input data as 18 February 2022. I expect the output as 17 February 2022, that is the previous date. So this is the expected output. If the program provided me expected output, I will consider this pass, else fail. Now we have invalid input date. What does it mean? Suppose in April month we have 30 days and I provided invalid input for 31/2022. So this is invalid input, so I expect program will provide output as invalid input date. Now we will try to understand that how we can generate the test cases for this program. So here you can see the input value range for this program. Here you can see we have different constraints. Value for month should be greater than or equal to 1 and less than or equal to 12. Day value should be less than equal to 31 and greater than and equal to 1. And year value should be greater than or equal to this one, and it should be less than or equal to 2025. Here we will use the boundary values. So for this example we will use the boundary values to design the test cases. So here we have certain testing levels: unit testing, integration testing, system testing. Unit testing, here we have two types: white box and black box. White box testing is code based and this is specification based. For this example we are using black box testing technique, boundary value testing. Now for n variable, now for a function of n variable, according to single fault assumption theory, for n plus 1 test cases can be designed. And here we have the value for n, 3. So they are the problem variables, and here we have 3 input: month, day, year. So we can design 13 test cases for this problem. Done. For others, suppose for the worst case boundary value, we can design 5 raised to power n test cases, and for worst case boundary value analysis we can design 7 raised to power n test cases. Now you can see we have 13 boundary value test cases designed here, as you can see here. And you can see for the first test case, input is 6, 15. The previous date is expected as output is 14 June. And here you can see we have invalid date. So because we provided here invalid data, in June we have just 30 days, and here invalid data is provided as input. So we expect the program to provide us invalid date as output. So this example is also provided in software engineering book, and many more examples you can see in that book for better understanding. Now you can see here, as we have different techniques for black box testing, now we have white box testing approaches. Using these approaches we can design the white box test cases. So here you can see first we have statement coverage. In statement coverage, our aim is to design the test cases so that every statement in the program executed once. In the branch coverage, this is also known as edge testing, and here our aim is to design the test cases to make branch condition true and false. Next we have path coverage. Here we will design the test cases such that all the linear independent path of program executed at least once. Here the linear independent path is also known as control flow graph. Here this one you can see. So this describe the sequence of different instruction of the program get executed. So testing is done to ensure that software is working properly as per customer requirement and even after update or any modification. So when program is updated, maybe there occur any error. So for this we will use the regression testing. Regression testing ensure that software is working properly even after modification. And here it ensures that no new error or fault is introduced and all test data suite is executed for testing when any change is made. Now we have mutation testing. Mutation testing produces a series of faults, and big programs have a number of mutants. It means faults. So faulty version of any program is known as mutant. We can kill or fix the faults if our test case can detect the faults. Now you can see we have different testing tools. Static and dynamic. You can see in the static we have static analyzer, code inspector, standard enforcers, and in dynamic we have, and you can see we have different dynamic testing tools. After that you can see we have the search based software testing. Now we will try to understand what is the search based software testing. This is the meta-heuristic optimization search technique that we can use for the optimization. So using this we can solve the optimization problems in the software testing. So here problem specific fitness functions are used to guide the search toward the good solution. Search based software testing was used by two American researchers in 1996 to generate the test data. And here they used input as floating points. For example, you can see here for this example we use input as these values. So they use the input in the form of floating points, and then they use the cost function, or you can say fitness function, for the performance evaluation. And after execution they divided the input with low cost and discarded the input with higher cost. You can see we have different design strategies in the software testing: bottom up approach, top down, hybrid design, function oriented design, that we will cover in another video. Now we will try to understand the role of meta-heuristic optimization in software testing. So our prime goal is here to find the optimal solution. We can perform optimization either to minimize or maximize. We can minimize cost, risk, time, and we can maximize profit, or we can maximize the fault coverage. After that you can see we have meta-heuristic optimization, single objective or multi-objective optimization. In single objective optimization we will use the single objective function to perform the search process, and in multi-objective optimization we will use more than one objective function to perform the search process. Now you can see we have certain challenges in the software testing. For example, safety and security is the main issue in the software engineering. Coder at Google makes more than 20 changes per minute in their source code, and 100 million test cases get executed per day for security and privacy. Next you can see here we have next issue, that invalid input test. So if you will provide the invalid input data, you will obtain the invalid results, and this may cause failure, faults, and other. So here you can see other issues related to fault, such as undiscovered fault, they are unknown to us, and then time consuming. Testing is very time consuming and costly. So here we have certain challenges. So as I told you, in multi-objective optimization we can use more than one objective function and perform the search process. So here in software testing, either we can maximize the code coverage or minimize the cost, or we can maximize the code coverage and minimize the cost and maximize the fault detection, or we can maximize fault detection, minimize cost. So it depends on the problem that you are trying to solve. After that you can see we have test case optimization technique for the different types: test case generation, selection, prioritization. Prioritization is either version specific or it is general test case prioritization. In version specific test case prioritization, it is for specific version of any software, and we can use this for any version of software. And after that you can see we have goals for test case prioritization. Either we can minimize the cost, maximize the coverage, or maximize the fault detection rate. And now you can see we have different types of test suite prioritization techniques. First is random ordering, where we will provide the random order to the test cases in the test suite. And in statement coverage, we will count the number of statements covered by each test case, and then we will rank them, and then we will rank them in the descending order. In the branch coverage, we will give the higher priority to the test cases that cover maximum branches. In the fault coverage, we will give the higher priority to the test cases that cover maximum faults. After that, you can see we have the certain test case prioritization approaches based on coverage-based, cost-based, historical information-based, time-based, risk-based, model-based, BAP-based, UI-based, requirement-based. Now we will use the meta-heuristic approaches to solve the test case prioritization problem, and already different types of meta-heuristic optimization algorithms are used to solve software testing problems. For example, PSO, ant colony, cuckoo search, butterfly, taboo search, genetic algorithm, firefly algorithm, and many more. Now we will try to understand how we can apply the gray wolf optimization algorithm to solve test case prioritization problem. For more details related to this algorithm, you can check this video. Here everything is discussed in detail. This video just we will focus on the key points. For better understanding, you can check this video. Now we will discuss first the key points required here for this algorithm. So gray wolf optimization algorithm mimic the leadership and hunting mechanism of the gray wolf in the nature. And as we know, gray wolf live in the pack, and their pack size can be 5 to 12. Done. So here we have 4 different ranks of wolf in the pack: alpha wolf, beta wolf, delta wolf, and omega wolf. Alpha wolf is considered as the leader. This is the pack leader, and he will lead the pack during hunting. And hunting process contain 3 steps. First, they will search for the prey and then encircle it. After that, attack. So alpha wolf is the leader, and entire pack follow alpha, and during hunting, the hunting is guided by alpha wolf. So when any target enter in the wolf territory, then they search the target and circle it, as you can see, and attack. So this entire process is guided by alpha wolf. Alpha wolf can be male or female. So alpha wolf is considered as the fittest solution. Beta wolf is the second best. Delta is the third best. Now we will try to understand how we can solve test case prioritization problem using this algorithm. Here in this algorithm, we have input as n number of gray wolf in the pack, and each wolf is the separate single solution. And here in the population, each wolf will represent the single test case prioritization order. The next question is how wolf will represent the test case prioritization order. For this, as you can see, alpha wolf is considered as the fittest solution, as we know that alpha is the pack leader and everyone follow alpha in the pack, and all the important decisions related to hunting, sleeping places, time to wake up, they are made by alpha. So this is the fittest solution. After that, we have the beta wolf. Beta wolf is the second best candidate after alpha, and beta wolf provide feedback to the alpha wolf and beta wolf, and after, so if any case alpha wolf is dead, then beta is considered as the new pack leader. Next we have delta wolf, that is the third best solution. Delta wolf dominate omega wolf, and it alert the pack in case of danger, and it provide food to the pack. Then we have omega wolf. Omega wolf is the lowest rank gray wolf. In this pack we have caretakers, elders, and hunter. So we will rank the test cases according to their order. After that, you can see we have wolf pack. As single wolf represent separate solution, so wolf pack represent the multiple test case prioritization order. After that, you can see here we will use the fitness function values to represent the solution in the test in the search space, and we will use the Wolf vector to represent the test cases in the algorithm, and we will use the index to represent the test case position in the test suite. Now for test case prioritization problem, how we will decide solution quality. Here we will use the fitness function, that is average value of fault detected metric. Here we will calculate the APFT values for each wolf, and highest average percentage of fault detection value is at first rank, second highest second rank, and third rank, and accordingly. Here n is the total number of wolves in the pack. Now next question is how we can calculate the APFT value. Suppose we have any test suite and it contains n test cases. Here we have no particular order for the test cases in the test suite. T dash, this is the output that contain prioritized test cases. You can see here input we have no particular order, and here output we have prioritized test cases. And F is the set of faults detected by test suites. And here this represents the first test case in the priority of the output, and second, third, so on. So using this we will calculate the APFT value for each wolf. For example, you can see here we have 4 test cases and 4 faults. As you can see here, first test case detected first fault, so here value is 1. Second fault is also detected by first test case, value is 1. Third and fourth fault are not detected by this test case. Now we will move to the second test case. Second test case detected third, fourth fault, thereby that's why value is 2 here. Now we will calculate the value, and then we will priority the test cases according to their capability to find faults. And here you can see after that we will generate the priority sequence. You can see certain steps are followed by Gray-Wolf optimizer to solve test case prioritization problem. First we will initialize the population for the n wolf in the pack. Here each wolf represents the test case order, and we will use the fitness function to calculate the fitness value for each wolf using APFT metric. And here alpha is the best, beta second best, omega third best, and this is the fitness function that will evaluate their performance. Now we will check the stopping criteria, that is the maximum of iteration. If it is matched, then stop. If it is not matched, then move to the next step or repeat the loop. Now we will update the wolf position in the pack, and after that we will evaluate their order and then update the parameters. And after that, now we will identify the redundant test cases using the cost function. Test case ranking is done from least rank to the highest rank, and if any fault covered by the test case is already covered by the higher rank, then we can remove that test case. And in the end we have the final output as the optimal order, that is the prioritized and minimized list of test cases. For this example, as you can see here, fourth test case covered all the errors it contained. After that, second test case covered third, fourth error, so we'll prioritize them. First this one, second this one, and then this one and this one. So this is the final sequence that we generated here. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.